Okay, so let us continue for our discussion for trial exam section A. Okay, so the question 1, calculate the enthalpy change for the following reaction. Calcium oxide react with carbon, okay, and become carbon monoxide and calcium carbon 2 here. So give the enthalpy of formation of calcium oxide, CaC2 and carbon monoxide. So the given value here is, okay, these three value. Okay, so for this, what is the enthalpy of formation? This one we also already discussed at our section B and C, okay? Okay, so according to the definition, the enthalpy change when one mole of substance is formed from its constituent element under standard conditions. So that means we have to get CaO from the constituent element. So the equation will be like this. Okay, calcium react with oxygen becomes CaO with one more. Okay, and then this one, calcium with carbon, we get CaC2. Carbon monoxide, we get this. So this one, you have to know that from the information given by the question. Okay, so from here, you can see the reactants will be CaO here. So that means we have to reverse this equation. Okay? Okay, so it will become like this. CaO will be the reactants together with carbon. So that means that the equation 2 and 3 here will be maintained as this position. So that means that here we just reverse the first equation as the reactants is CaO here. Okay, so we cancel. So you'll get the same equation. The overall equation will be same as the question given here. Okay, so from here, we just need to plus all the enthalpy here. So we get the answer here will be 111. So here answer is B. Next. Okay, so an element Z has the following successive ionization energy in kilojoule per mole. Okay, so from here, the question given that the first ionization energy will be 570. Second will be keep increasing. But here, you can see that the difference for the first ionization between first and second will be about 1,400. And then for the ionization second to third will be also about 1,000. So that means the increase of the enthalpy will be almost the same. But here you can see when reach the enthalpy change at the 7th ionization, so the enthalpy change here is about 6,000 plus already. So that means that from this, we have to know this is actually the 7th electron will be removed from the second outermost of the shell. Okay, so that means here there is a 6 valence electron for this element. Okay, so first, the proton numbers is actually provided. So from here, you must be able to form the electron configuration. So from here, A, the potassium will be only 1 electron valence. And then the second, scandium, 21. So the electron valence here will be 3. But just how we explained already, so we should get the element which is have the 6 valence electron. So the C, titanium, will be only 4 valence electron. So for the last chromium will be 6. So this question is actually easy. Okay, you should be able to do. Okay, so the answer here will be D. Okay, so now we go to question number 3. Let us read the question together. The reaction occurring in the Daniel cell is given below. So this is the reaction. What happens when the EMF of the cell drop to 0? So the EMF cell becomes 0, what will happen? Okay, so here is the common formula we're using for calculate the EMF. So here will be the E0 value for the cathode, and here will be the another E0 value for another half cell, which is at the end of here. Okay, so when the EMF becomes 0, so from here, the E0 cathode will be equal to E0 cathode here. So that means the best answer here will be C, where the electrode potential of both half cell have the same value. So the answer here will be C. Okay, now let's look at the question number 4. There are 4 half equations given here with their respective E0 value. So under standard condition, which one of the reaction is possible to occur? So we have to check the all 4 overall equation here. Is it able to have the reaction? So for checking the flexibility, we're using this formula. We add on the reduction E0 together with the oxidation E0 here, and the E cell value positive, showing that there will be the possible reaction occur. So let us check the flexibility for each equation here. So for A, from here you can see the reactants will be oxygen. So this will be the equation number 1. So and here the equation 1 will be the reduction reaction with the E0 value positive 0.68. Another reaction here will be oxidation reaction with the reactants of the Fe2 plus here. So they will be at the right side of the equation for the oxidation reaction occur. So from here, you can see the Fe2 plus will be shift to the right, and the E0 value here have to change to 0.77. So we add on these 2 values with this equation. So we get our value will be negative 0.09. So the negative value here showing that this reaction will be not occur. Next, we look at the flexibility for checking for the equation B. So from here, the reactants will be Ce4 plus. So for B, the reactants will be Ce4 plus. So will be here. So this will be the reduction reaction with the E0 value here. So for another reactants here will be H2O2. So for this reactants, there will be 2 possible equations here, but we have to choose first equation. Since there is already have the reduction reaction for Ce4 plus, so that another reactants must be undergo oxidation. So that means the first equation, the reaction will be shift to the left, and the E0 value here will be negative 0.68. Okay, so we add these 2 values, we get our E0 cell value is positive 0.77. So the positive value showing that this reaction will be possible to occur. Okay, so the answer should be B. So now let us check the another C and D overall equation. So for C, the reactants here will be Fe3 plus. Okay, so that means this will be the reduction reaction for this overall equation with the E0 value positive 0.77. So the another equation here will be the reduction sorry, it will be the oxidation reaction for the water here. So that means the reactants will be at the right. So will be equation number 2. Okay, so since this is the oxidation reaction, so the reaction will be shift to the left, and the inert value will be negative 1.77. So we add on these two values, we get it will be +1. Sorry, so the inert value here will be -1, and the negative value of the inert cell showing that this will be not possible reaction to occur here. Okay, so this will be wrong. Okay, and the last equation will be D. The reactants will be Fe3 plus here. So for this will be the third equation with the reactants Fe3 plus and undergo reduction reaction here. So the inert value here will be positive 0.771. And another reactant Ce3 plus will be this equation, which is undergo oxidation reaction here. So the inert value will be negative 1.45. So we add on these two values, we get the E cell value will be negative 0.68. So the A, C, and D showing that the E cell not in negative value, so there will be not any reaction will be occur. Okay, so the answer here will be B. The reaction will be occur with the E cell value positive 0.77. So the answer is B. Okay, so next we go to question number 5. Which of the following solid show more than one type of chemical bonding? Okay, so here for A, brass is the alloy, copper zinc is a zinc, is a copper zinc alloy. Okay, so there will be there is a metal alloy, so that there is bonded with a metallic bond only. So this is only one type of chemical bond. Then the second, copper is a metallic bond also. Diamond will be covalent. Then the ice will be have two chemical bonding here, covalent between the atom for the molecule of water, and then there is a hydrogen bond here. So the answer will be D. Okay, so this is a figure lah. So here will be hydrogen bond. Here will be the covalent bond. Okay. Okay, then for number 6, the solubility of group 2 sulfide decrease from the magnesium to barium. So which of the following best describe the changes in the value of the lattice energy and hydrogen energy going down group 2 sulfide? Okay, so the keyword here is the lattice energy and hydrogen energy. Okay, so here for the lattice energy, so the size of the group 2 action K ion increase down the group. So that means from magnesium to barium, the size for the element will be increased. Okay, so this lead to the increase in inter-ionic distance. Okay, so causing the decrease in the electrostatic attraction between the K ion and N ion. So that means the sulfide and the K ion given here, so the distance will be keep increasing, so that the electrostatic attraction between the K ion and N ion decreases when going down to the group. Hence, the lattice energy decreases. So here, they will become less exothermic for the lattice energy. While for the hydration energy, okay, so the hydration energy released when there is a result from the ion dipole attraction between the K ion, okay, with water. Okay, you can see here. So the dipole attraction is between the water together with the K ion. Okay, okay. So when we discuss the group going down, so the size increases. okay, for the cation. So that means the dipole attraction between the cation together with the water decreases. So hence, this will be causing the hydration energy also decrease. So actually both the lattice energy and hydration energy decreases for question number 6. Okay, so that means the answer here will be A. Question number 7, the hydration iodide is stronger acid than hydrogen chloride here. Okay, so it will be Hi together with HCl. Which of the following statement best explain this observation? Okay, so if you go through the answer A to D, okay, so why Hi will be a stronger acid? So this is the question, key question here. Okay, so from here you can see the iodide ion here is bigger compared to the chlorine ion. So that means the bond of the Hi will be weaker. Okay, because the size of I is big, so cause the length between I and H will be longer. Okay, so that means the Hi will be tends to produce more H positive ion here. So for the acidity, so when the H plus ion is small, so there will be more stronger acid. So we have to discuss regarding the bond between the halide together with hydrogen. Okay, so the answer here will be D. The covalent bond in the hydrogen halide is weaker compared to hydrogen chloride molecule because of the size of the iodide is bigger, causes the Hi bond become longer and the strength become weaker between H and I, so that will be form more H plus ion and become stronger acid here. Okay, the statement A is already wrong because the hydrogen bonding between the hydrogen halide is only exists for the H and F. Okay, so answer is D. Okay, so for question number 8, a pale blue precipitate is formed when drops of ammonia solution are added to copper 2 nitrate aqueous. So when an excess of ammonia solution is added, the precipitate dissolves given a deep blue solution. So which process is not present in the above reaction sequence here? So we have ABCD, which is not present. Okay, so the first, what is pale blue precipitate here? This will be copper hydroxide. You may refer to the table in chapter 7. Okay, so copper hydroxide will be in blue precipitate. And then second, deep blue solution will be tetra amine copper 2 ion. Will be this. Okay, so the reaction here will be like this. So the copper 2 nitrate will be providing the copper 2 plus ion. Okay, when there is only few drop of ammonia solution added, so the precipitation of the copper 2 hydroxide, which is in pale blue color, will be like this. Okay, so this will be the copper 2 plus when there is only small amount of ammonia. So the precipitate of the copper 2 hydroxide, which is in pale blue color, will be appear. Okay, so when we give excess of ammonia, so the complex ion will be formed. Okay, so the complex ion here will be this lah, tetra amine copper 2 ion. Okay, so from here, first we already sure that the formation of complex ion is occur here. Okay, which is the deep blue solution. So it's present lah. And the second, you can see there is a dative covalent bond formation here. There is 4 dative bond here. And then the precipitation of copper 2 hydroxide is formed with the few drop of ammonia. This is a pale blue precipitate, which is a copper hydroxide here. So the C is wrong. Why? So here we do not have any reduction process here. So the answer is very clear. This is C lah. Okay, so question number 9. The following is attributed to high polarizing power of aluminium 3+ ion, except which one? Okay, so the first, high lattice energy of aluminium F3 here. Okay, so we have to see which statement here showing the anomalous properties. So for the first A, so this is actually an ionic bond between aluminium and fluorine. So this is not any anomalous property for the aluminium 3+ here. Okay, this because the fluoride ion here is too small to polarize by the aluminium 3+. So there will be normal ionic bond between aluminium together with fluorine here. So the answer is actually A lah. Okay, then for the second B, formation of the complex by aluminium. Okay, so this will be form complex ion for the aluminium 3+, because the aluminium 3+ has a high charge density. Okay, so it able to attract lone pair electron from a ligand to form complex ion. Okay, so the equation will be aluminium 3+ with the O- hydroxide ion here and become the complex ion. Okay, then the C, aluminium chloride is covalent, okay, with high polarizing power. So it is able to polarize a big N ion readily by dissolving significantly their electron cloud and form covalent bond with ionic character. So the aluminium Cl3 is one of the example there. So this is also showing the anomalous property for the high polarizing power for aluminium 3+. Then for D, acidic solution formed when salt of the aluminium solution is in water, dissolved in water. So the salt aluminium will be referring to AlCl3. Okay, so AlCl3 has polar covalent bond and aluminium ion will be formed. So this will be the formula. Okay, so aluminium ion will be polarized the electron cloud of the water molecule, okay, and weaken the OH bond. So the H will be positive. So H positive will be released, and the reaction will be this. Okay, so the hyposodium ion will be formed and cause the solution become acidic. Okay, you can see the equation will be formed H3O+ here. Okay, so this is the theory behind the question. So the answer will be A. Okay, so let's continue question number 10. Okay, so which one of the following statement about the tetrachloride group 14 element is not true? Okay, so for A, okay, so for A, the covalent bond in the tetrachloride get longer from carbon to lead. Okay, so because of the size is increased, so the bond length will be increased. So for this will be correct. Okay, then for B, all the tetrachloride liquid at room temperature. So this one also correct. Okay, so the A is correct. So B, all tetrachloride group 14 elements exist in simple molecule. Okay, so all the volatile colors liquid is at room temperature. So because of the simple molecule, so that exists as liquid also. Okay, then for C, all the tetrachloride are hydrolysis at room temperature. So this one will be wrong. Okay, as we know that the carbon do not have any d orbital. Okay, in its valence shell, so it cannot expand its valency to form a coordinate bond with water. So the main reason is because of no orbital d orbital for carbon. So that means not all. So others will be hydrolysis together with water except carbon. So answer actually is C. Okay, so this one wrong already. Okay, so D, the tetrachloride become less stable for carbon to lead. Okay, this one correct. Okay, because we know that for the lead, they will be stable at +2 oxidation state. And the size is also increased cause the bond length increase. Okay, so the strength of the stability, okay, because of the strength decrease, so the stability of the thermal is also decreased. Okay, so the answer here is C. Okay, so question 11, which of the following correctly show the change in the oxidizing strength and the electron affinity of the halogen when going down the group, okay, from fluorine to iodine? Okay, so here, the first, the oxidizing here means that itself is under reduction, so it will gain electron for this statement. For the electron affinity is referring to ability to receive electron, so that means both will be more easier to get electron. Okay, so when size increase from fluorine to iodine, so the attraction of the nucleus to valence electron decreases. So that means the ability to receive electron will be decreased for both. Okay, so answer is A. For question 12, so iodine dissolved in aqueous potassium iodide to form I3- ion. Okay, so however, borate 3- ion does not exist. So why? Okay, so for formation of the I3-, okay, so this is the structure. Okay, so it's formed by the bonding of I2 with I- ion. Okay, so where electrons are usually accommodated in empty d orbital. Okay, so that means for formation of the complex ion here, so they need d orbital. Okay, so from here, so this is a periodic table. You can see iodine is at period 5. So the d orbital will be exist started at period 3. Okay, so you can see fluorine is actually at period 2. So that means the fluorine is actually do not have orbital d to expand its octet. Okay, so that's why there is no F3- ion is exists due to the period 2 elements do not have any orbital d. Okay, so this is the reason. So answer is B. Okay, and then the question 13, which of the following graph best describe the variation in the first ionization energy across the period 3? So generally, for the first ionization, that means they want to lose one electron, right? The first ionization is increased when across the period 3. So this is because the nuclear charge increase, the proton number is increased, right? So the nuclear charge is increased. So we expected actually the first ionization is increased like C. Okay, but there is an exception where occur at malaxium. Okay, so why? You can see the electronic configuration for the malaxium. So will be like this Okay, because we know the proton number for malaxium is 12. So the configuration electronic will be like this. So when the malaxium orbital 3s is fully filled, so it is more stable. Okay, so malaxium is higher than expected for the first ionization. Okay, because the first electron to remove from the fully filled s orbital, which is more stable. So that means more energy is required to remove one electron from the fully filled orbital. Not only 3s, but others also the same. And then another will be at the phosphorus. Okay, so this is the configuration. So the phosphorus have proton numbers of 15. So you must able to give the electronic configuration for the phosphorus 15 here. from here you can see the 3p orbital is half filled. So when the orbital is fully filled or half filled, it will become more stable. Okay, so phosphorus is expected higher first ionization energy compared to others lah. Okay, so this is because the first electron is need to remove from half-filled p orbital, which is more stable. Okay, so conclusion here, when come to the remove of the electron from the fully filled or half-filled orbital, it will be more stable and more energy will be required to remove the electron from these two type of the orbital. So here we are very clear, answer will be A lah. Okay, and then the next 14, which of the following statement does not show the characteristic properties of the transition element? Okay, so to understand the character of the transition element, okay, here we have 4 special chemical properties here for the transition metal you have to memorize. Okay, so the first, exhibit variable oxidation state. So that means the oxidation state for the transition element will be more than 1. Okay, and then second, the formation of the complex ion. Then third, normally they have a color, okay, and show the catalytic properties here. So this is a 4 character for the transition metal. Okay, so for A, but the question here is ask you to find out which is not showing the character for the transition metal. Okay, so here, nickel is used during the hydrogenation of vegetable oil to solid fat. Okay, so as we know, for the process of the hydrogenation, actually is change the double bond of the carbon, okay, which is unsaturated for the vegetable oil to become saturated, which is only single bond between the C. Okay, so however, here we discuss for the hydrogenation process, nickel will be act as the heterogeneous catalyst. Okay, act as the heterogeneous catalyst because they can use the d orbital to carry out this process lah. Okay, so that means nickel showing that there is a catalyst property lah. So second, D, the oxidation of the manganese has the formula. So from here, you must able to get the oxidation state for manganese to be +2. Then for MnO2 will be +4, and here will be +2.67. So that means overall, these 3 oxide of the manganese showing that they have the different numbers of the oxidation state. Okay, so that means the first character here also correct. So A and B showing that there is the chemical character for transition element. So for C, iron react with dilute acid to give hydrogen. Okay, so iron here is actually metal, and the reaction together with acid will be release hydrogen. So metal plus acid becomes salt and release hydrogen. For this reaction, not only transition element showing the same reaction, but actually others metal such as the metal from group 2. Here I given the example of the malaxium will be react with acid and form the salt and hydrogen. So that means this reaction is not belong to transition element, but also for others metal. So that means this is not the answer lah. And then for D, copper 2 hydroxide dissolved in excess aqueous ammonia. Okay, this one we already discussed at the previous question. Okay, so here this is a reaction actually. Okay, I mentioned here. So when excess aqueous ammonia is added to aqueous copper 2 hydroxide, okay, so a deep blue solution will form. So this is a complex ion, which is this lah. Tetra amine copper 2 ion here. Okay, so that means D also showing the transition elements properties lah. So the answer here will be C, because the reaction is not belong to transition metal only, but others metal also have the same reaction. Okay, so we go to last. Which statement is true about the transition element vanadium to copper in the periodic table? Okay, so firstly, you have to know that the vanadium to copper will be at this position. Okay, at this position. Okay, from proton numbers of 23 to 29. Okay, so A, the 4s orbital is fully filled. So it's correct or not? So here, actually, not correct, okay, because chromium, there's the valence electron configuration at this 3d5 4s1. Okay, why the electron not fill up the 4s orbital first? Because the 3d5 showing that this is a half filled orbital, which is more stable. So the electron will be more tends to fill up 3d become 3d5 orbital compared to become 4s. Okay, so that means 3d4 4s2 will be not stable. So it tends to become this configuration to become more stable due to 3d5 is half filled orbital, which is more stable. Okay, then another one will be the copper. Okay, so for copper also the same. The valence electron configuration will be like this. So the fully filled 3d orbital will be more stable. Okay, so that means from here 3d9 4s2 will be not stable. So it will be more stable in 3d10 4s1 for copper. So that means these two elements showing that not all 4s orbital will be fully filled for vanadium to copper. Okay, so this one wrong. Okay, so here very clear, wrong. Okay, then for the B, the atomic size decreases significantly. So this one also wrong actually. So why? Okay, so from scandium to zinc, from here to here, the numbers of proton in the nucleus increases. So that means the nuclear charge is actually increases. However, when the proton number increase, there is actually adding the electron also to the inner 3D subshell here. So that means the screening effect is also increasing due to the additional of inner electron here. Okay, so they cancel out each other. The effective increasing nuclear charge will be like normal. Okay, so the effective nuclear charge will be not much change. So that means the size will be almost the same here. So the decrease will be wrong because they will be almost the same. Okay, so this one wrong. And then C, the most stable oxidation state will be +2. So this one also wrong actually. You can observe this graph. Okay, so this is E0 value for the transition metal here. Okay, so here we have a line which is 0. Okay, so that means that the value below the 0 will be negative. So the titanium, vanadium, and chromium showing that the E0 value here is negative. So the negative, that means that the reaction will be shift to left. Okay, so that means for these three elements, okay, so they will be more stable at +3 oxidation state. Okay, so that means the vanadium is one of the example here, which is will be stable at +3 oxidation state. So this statement is strong. Okay, then another three. Okay, here we have the manganese, ferrum, and cobalt here. So the value for E0 will be greater than 1, so it's positive. So the reaction will be tends to shift to right. So that means for these three, +2 oxidation state will be more stable. So that means here actually they are able to stable at +3 or +2. So this statement will be also wrong. And then the last D, the first ionization energy are almost the same. So this one will be correct. Since this three already wrong. But the statement for the D is actually almost the same explanation for B. Okay, which also regarding the nuclear charge shading effect. Okay, so here the electron are removed from outer 4s orbital, which is shaded from the nucleus by the increasing screening effect. Okay, so when electron is added for 3D orbital, okay, so that means the repulsion between the inner electron at 3D will cause the effective nuclear charge become not much different. Okay, so this is the difference between transition metal with others comparison. Right, we compare the period 2 and period 3. So we can see that nuclear charge decrease. Overall, the radiance actually decrease for the period 2 and period 3. But for the transition metal, the overall increasing of the nuclear charge will be cancelled out by the shedding effect due to the repulsion of the inner electron. Okay, so overall, the nuclear charge effective will be not much changes. So that means the size will be almost the same, and the energy for the first ionization will be also almost the same. So here, correct, okay, because here mentioned almost a constant. Answer will be B. Okay, so that's all for my discussion for trial exam.